Yeah. So everybody, this is Xiang from the Biotron, and I'm going to answer the questions you sent to Dong and to pass the question to me. I saw the file, basically three parts of the file. First part is about the HPV testing. The second is working principles. And the third part is the specimens and trial. The first questions from the first part is VIA is a main testing method for the cervical cancer in Indonesia. And what is the strengths and the weakness compared to VIA and the cytology test? My comments for this question is actually in China. In China, the golden standard for the cervical cancer screening still is still cytology, so-called TCT and VRA. But compare these two methods. The HPV test, we can call this is a non-invasive test compared to the VIA. We know the VIA caused a lot of damage, and sometimes the VIA is not necessary for certain patients. So basically, the strength for the HPV testing is it could be high throughput. So high throughput. So that's the efficiency of the screening is much better. And the weakness is the HPV test basically is a screening test. It's not a confirmation. So when you have the HPV test positive, you have to go through the maybe TCT and the VIA testing. That's my comment for the first question.
Okay. Sorry, can I ask a question? Yes. So you said
anytime.
Yes. So you said that HPV testing is usually for screening and not for confirmation, and usually the patient already goes through other tests before HPV. Is that right?
Yeah. Other tests like a TCT, like a VIA.
Okay. Okay. So you mean so as I mentioned in the question, the situation in Indonesia is the screening for HPV among women is very, very low. The screening number is still below 10% for women at risk in Indonesia.
Okay.
And so we are looking to improve this. We're looking to improve this number, and then we want to offer HPV testing, especially by RT-PCR, as a good alternative. So we want to know, how can we promote this, and what are the strengths and what are the advantages of using HPV? And because the biggest disadvantage is that HPV testing needs to be done in a lab with complex technology, and it's quite expensive compared to VIA other tests. Yes, So what do you think about that?
Actually, from my point of view, the HPV testing is recommended by a lot of guidelines for the cervical cancer, including the China, the European, and the United States. And that's the first that they go to the guidelines. So that they could be there is a recommended method to screening the cervical cancer. That's the first one. And the second, that although there need professionals to perform the test in the lab, but this HPV test, especially use the RT-PCR, can be high throughput. So that basically, if you use our RT-PCR, one batch of experiments can screen like 96 people, close to 100 people, and it's only requires the people with the PCR certificate. And if you go to the TCT or VRA, you need the doctors and you need the pathologists. Pathology is really limited in China in the situation. I think the same situation in the Indonesia. I think the pathologist is really limited. So That's the second. And the third one is regarding the technical, because the HPV can predict the cervical cancer much earlier compared to the TCT and VIA. And if you have the patient have the HPV screening negative, it means at least 2 years to 5 years they are free of cervical cancer. This will also go to the guidelines. So that's the very strong point. You can find the HPV of cervical cancer much earlier compared to the traditional ways like TCT and VIA.
All right.
So that's my comment.
Okay. Then connected to your answer. So for the other test, let's say VIA, because we can only detect it after it has some changes, right? Some progression is
yes, right.
Yes. So let's say for HPV, you said when the result is negative, then we can assume that the person will not have cancer for the next 5 years. So we can repeat the test only once every 5 years, correct?
Yes.
Okay, then how about VIA?
That's the. Sorry, I'm sorry. Go ahead.
No problem. Yeah. So how about the other test, like for VIA? If the result is negative, when do you suggest that the patient should repeat the testing again?
In China, they suggest any woman like age over 40, they should do the TCT or VIA every year, at least once every year. Yeah, I'm not sure the policy in Indonesia, but this is in China.
Okay, I see. Okay, then in China, how among all the screening for cervical cancer, how many percent of that is using HPV testing? Approximately.
Right, I think at least 40%, at least 40%, especially in the city. Right? Yeah, in the city, the government right now is promote the HPV test for the screening of the cervical cancer, and because there is a lot place, a lot of villages and the remote area, their economic situation is really not that good. So sometimes this policy need a lot of time to penetration to the remote area. But for the larger city, I think that at least half of them go to the HPV screening center. So overall, I think the 40% is, is a very promising.
Okay, I see. Yeah. All right. And then back to the question about, so HPV testing can be used as early detection. So let's say if a person has HPV testing and then they are confirmed to be positive for HPV, high-risk HPV, say HPV 16, for example, and then but they don't have any visible changes yet, physiological change. So can we say like the chance of this person developing cancer, like how many percent approximately? Is it possible?
Yeah, no, actually, this is a very complicated questions, because the HPV positive, they're HPV positive, they're in the guideline in China, for the China's FDA and for the HPV positive, if you have a HPV positive, high risk, and if we have 16, 18, these two is to go to the VIA, to do the VIA. That's the one thing. If they see no change in the morphology of the cells and no change, they say no changes, and the people ask to come back within half a year.
Okay.
And there are people, if their HPV 16, HPV 18 is negative, but other high risk HPV is positive in China, the people be asked to come back to within half a year and to do another testing. To the answer, they don't have to go to VIA, but they ask you to come back within half year.
Okay.
6 months. Yeah.
Okay.
And if they have the HPV negative, that means with 2 years you don't have to come back.
Oh, HPV negative is 2 years. Okay.
Yeah. Yes. The Kaijin, original the Kaijin, you mentioned the hybrid capture, the Kaijin
Yes.
AC HC2, they ask 5 years to come back if they're HC2 negative. That's 5 years. But China right now is 2 years come back.
Okay. I see. Then let's move to the next question then. So our team in Enviro, we are quite familiar with real-time PCR, but not with HPV testing. So we are still unsure what makes RT-PCR different and what are the strength and weaknesses of HPV testing using RT-PCR compared to other tests like hybrid capture and gene chip, as you mentioned.
Yeah, there's a lot of method applied to test the HPV DNA or RNA. The most famous used is the HC2 from the Kaijin, and there is a lot of company from China or from outside of the world, like the Kaipu in China. They use a gene chip, and there's company Luminex from the US. They also use the chip. That is the liquid gene chip, the Luminex Bicode. And this method, basically, they're all testing the DNA of HPV. The advantages for the RT-PCR is first, the RT-PCR is much more sensitive. That's one very strong advantage, strong point, very sensitive. And the RT-PCR is easy to perform. The HC2 and the gene chip really need the HC2 and the gene chip need a very special instrument. That's the instrument designed only special for the special the instrument, special from the company. So if you have if you use the HC2, you may order the instrument from Kaijin, and if you use gene chip, you have to order the chip from the Luminex or the companies. But for the RT-PCR, there's only the reagent. The need, there's an open system like any real-time fluorescent PCR instrument. Those kind of instruments are normally equipped by the many central labs or clinical labs. So that's the second one. And the third one is RT-PCR is, we call it a closed system. So you don't need when you do RT-PCR, the experiment end, and you can read the result from the computer. You don't have to do the hybridization or any other perform operations. By this way, they can avoid the aerosol contamination. So the RT-PCR can avoid the aerosol contamination, but the HC2 and the gene chip cannot have the risk for the aerosol contamination, which can cause the false positive normally. And in summary, the RT-PCR is simple, faster, and sensitive.
Okay, I see. For HC2, how long usually does it take to process the sample?
4 hours.
4
hours to 6 hours. Yeah, HC2 is 4 hours. Some gene chip needs 6 hours.
Okay, I see.
Yeah.
All right, I see. For earlier, you mentioned that RT-PCR is more sensitive, right, compared to the other?
Yes.
Do you have any data or report about that, or maybe some reference?
Yeah, there for from the MPA based HPV testing, our detection limit, LOD for the HPV different types is around 100 copies, 100 copies per reaction.
Okay.
But for the HC2 is 5,000 copies per reaction.
Okay, I see.
Yeah, the HC2. And the gene chip depends on different countries. Most of them, their sensitivity is close to 1,000 copies per reaction.
Okay. Okay, so it's quite far, the difference, right?
Yeah, because HC2 is the first HPV testing be used all over the world. It's kind of the gold standard for the molecular method to detect the HPV, but it's 20 years ago. Right now, the HC2 met great challenge in China, in the China market. The usually is the predominant in China, but right now is it lost a lot of market because of the sensitivity, because of the performance is very complicated. The operation is very complicated. And also another way is very, very expensive in China, the HC2.
Oh, is it more expensive than RT-PCR?
Yeah, much expensive.
I see. So we can say that RT-PCR is like an upgrade, a better method, alternative.
Yes. From my point of view, yes, right.
Okay, I see. All right. Yeah, I think about the testing, I think that should be enough. Actually,
Okay.
the next is about working principle. So I sent these questions because I thought there will be some presentation session about it. But
Sorry.
yeah, no problem. So
Yeah.
is it possible, maybe you can explain about this questions that I have about this, because
Yeah.
we're not quite familiar with this methods and concepts.
Yeah, our method is called MPA. There's a multiple probe amplification. That's the technical platform we adopted to develop the HPV high risk typing kit. And the MPA basically, I saw your technical team is here. If anyone familiar with the Techman probe based RT-PCR, they'll be much easier to understand the MPA. Basically, our method is based on the Techman probe, the RT-PCR. That's technique plus another probe. Actually, we call the one probe is THO. That is target hybridization oligo, which is equivalent to the Techman probe. So use this probe, we can use the RT-PCR to detect the HPV, any asset, any DNA, any DNA. We just design the probe to specifically target the specific region. That's the THO probe. Another probe we call the PCO. That short for partially complementary oligo. The PCO probe can bind into THO probe. This binding can form a melting curve. That's where is the melting curve come from? Where does the melting curve come from? So basically, the Techman assay has one probe, two primers. Our assay has two probe and two primers. So that's basically the difference. And how it works, basically it's a DNA hybridization. Basically it's like this. And I think after the meeting, I will prepare a technical file to explain to you how this probe works. Because I cannot depict this, use any words. So I need to draw some like a cartoon that you understand the principles of this method. So I prepare and I'll ask Don to send it to you.
Okay, that would be great, actually. Yes.
Yeah.
So is this technology used by all RT-PCR for HPV testing? All different brands?
No different. None. This method, basically, this is our patent method, patent technology. I think we are the only one, except the company in British. They call Gene First. Actually, we just purchased this company. We are the biggest stockholder for the company in England, and they call it Gene First. Actually, we get this technique from the Gene First and developed this assay.
Okay.
And I think there's only 2 companies in the world can use this method. Yeah.
I see. So what advantage does this technology give compared to other brands give?
Normally, we have 2 ways to compare. One is you compare to the regular RT-PCR. If you use the regular RT-PCR to do the HPV typing, and because we use the different fluorescent channel to differentiate the different targets. So normally, right now, our PCR instrument only have 4 to 6 channels, which means one tube you only can type in 4 to 6 targets. Actually, it's 3 to 5. You need to reserve 1 channel for the internal control. We call it IC. Yeah. So one tube you only can detect 3 targets or 5 targets. That's the limit of the typing. But use our method. You can use 1 tube, 4 channels, 4 fluorescent channels. Each channel you can differentiate 6 different targets. We use the fluorescent channels combined to the different TM, which is the melting point. We combine these two, and we can detect at least 24 targets in 1 single tube. That's the strength of this method. We can do the genotyping, target more than 20 targets in 1 tube. That's the key of this method.
I see.
Yeah.
Okay. All right. I think for further technical principle questions, I will just wait for your explanation later after the meeting.
Okay.
Yes.
Okay.
Okay. Then I would move on to the next part. So my question is about the sample, the cell for the testing. So can you explain how is it collected, transported, and stored? What are the requirements for it before we process with the kit?
Yeah, for the DNA test, actually the specimen requirement is not that rigid. So regulate collect the samples like we do the TCT, but we provide a special buffer. When you collect the cells by the swabs, and you put the swab into the special buffer, and this samples can stay in the buffer for at least 48 hours in room temperature. So that can be transported and stored at the room temperature for at least 48 hours for the DNA testing.
Okay,
and if you like, if you prefer, you can use commercial. That storage buffer can from Biotron, and also you can order from other company. And there is a company called the Hologen. Hologen. You can use the connection buffer from Hologen.
Okay.
So you have 2 ways: use the buffer from the Biotron and use the buffer from Hologen. And you collect the samples regularly, like you do TCT, and put the cells and the sample into the buffer and keep it in the room temperature for less than 48 hours. If you need a long-term storage, you can put in -20.
Okay.
Mhm.
Okay. So sorry, for the commercial buffer, in what temperature do we store again?
Room temperature for 48 hours.
Oh,
48 hours.
it's the
Yeah.
same as the Biotron buffer?
Biotron, yes. Actually, the Hologix, the buffer is really good. It's really good, but a lot expensive compared to the Biotron buffer. Yeah.
Okay, okay.
Yeah.
Then my question is does this buffer have a, like the commercial one, does it have a general name? Because I'm not sure if this product is available here in Indonesia. So what if like people want to test here?
Yeah, the Hologix, I sent you the category number for the Hologix, for Hologix buffers. And for the Biotron, you can just order from Biotron, or we provide for the first time, we provide the buffer and let you test or compare ours to Hologix.
Okay, I mean, how do we generally call this buffer? What buffer is this called?
They just call it the I can remember the name. I can remember the name.
Okay.
Yeah, for
Okay.
ours, just the VTM, that's a viral transportation media. For ours, the Bitrons called
Okay.
VTM.
Okay.
Yeah.
Okay.
I can remember I don't remember the Hologix brand.
All right. Maybe later after the meeting also, can you share the maybe some brochure or product specification about it? Yeah.
Sure.
So we can
sure.
study.
No problem. Yeah. No problem.
Okay. Then maybe we can move to the next question.
Yeah.
So
there's a criteria. Specimens criteria must be met. Actually, this one we just need you collect enough cells. I mean, enough cells for the experiment. Actually, if you don't connect enough cells, the IC will not amplified. So that means their sample is not enough for the experiment. So basically, no, just use this collect the sample and store it in the buffer and perform the DNA and RNA extraction within 48 hours. That's basically the requirement for the sample.
Okay. Okay. How much is enough for the sample approximately?
I don't have the exact numbers, but normally if you just use the swab, use a virtual swab to collect sample, just like the regular one use. That's enough for experiment.
Okay.
Don't worry, you don't have. Yeah, normally we don't worry about the not enough samples connected. That's real in the experiment. Normally we have enough.
Okay. Maybe recommendation on how to swap, how many times, or like the method in order to collect as much.
Oh. Okay. I will prepare. I prepare that one because I'm not sure the habit, because this one we prepared is based on the operation for the Chinese doctors, but I'm not sure whether the same thing in the Indonesia. Maybe your pathologists have their own operation procedure. But I prepare hours. I prepare the hours and let you just for reference. Yeah.
Yes, for reference. Okay. Okay, and then the next one is actually before this last one, I have another question. So we have received the sample, the kit sample, for about 200 or something tests, and then the ED is actually quite near, which is we were informed that the ED is in September, I think mid-September this year. Yes.
Okay.
I just want to ask, like technically, is it still possible to use it after the ED? Have you ever done any stability test and such?
Actually, we do the stability test. I think the suggestion the life share is 12 months. I think that's, but we do have data show that after 18 months, if you store the kit in -20 at or below, the kit work at least 18 months. 18 months. That's 1 year and a half. Yeah, that at least that's a real stability study.
Okay.
Real-time stability study. Yeah.
Okay, because we are looking to do the testing with a big national university here in Indonesia. So they have
Okay.
a university hospital, and then we will try to do the testing before September, of course. But just in case there are any issues and it's not possible for them to do. So is it okay for us to inform them, because this is not for commercial use, right? This is just for testing,
Yes.
trial. So
yes.
we can inform them that the real stability is actually for 18 months, correct?
Yes. Yes. Right.
Okay. 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 Understood. Right.
Okay.
Okay. And then still in that same topic, actually. So, because we're just going to do trial and we just want them to test the kit, because if we have their recommendation that the kit is good and then they can use it good for Indonesian, situation, then there's a huge chance it can help us in market the kit here. So maybe from Biotron, do you have any recommendation on how any method or trial details that that you feel necessary that we have to ask them, please do this, please do that?
The one concerns for the trial is the PCR instrument. Well, what's the brand? Yes, what's the brand of the PCR instrument? Because there might be slight difference in terms of the PCR programs when you use a different brand of the PCR instrument. Like if you use the ABI instrument, you may adjust the extension time and the temperature. And if you use the one from Roche, you maybe do the color comprehension. If possible, can you let us know the instrument you are going to use and the software versions, so we can test in here and give you the best optimized. The PCR programs, and you may get a better result by doing this.
Okay. Okay. Yes, I will inform you. But one thing, usually, because this is a national university standard lab, and it's they usually have a very, very big lab. So by standard, the usual instruments there are ABI. ABI is usually always available.
ABI, okay.
Yes, yes.
Yeah.
But later
ABI is our reagent. Yeah, go ahead. Sorry.
Yeah, but I will inform you later, like what kind of instruments they have, and then maybe you can do the optimization.
Okay. Okay. Good.
Okay. I think that would be it from me. Let me ask my team.
Okay.
Yes. Ayuni, Mbak Nick, ada pertanyaan? Silakan.
Enggak, Mas, sudah cukup.
Oke, dari pemakaian sudah jelas ya.
Yeah, Mas.
Okay. I think for now, that would be our question. I will wait
Okay.
for the documents that you will send after this, and maybe later, if we have further questions, we will try to summarize it and send it to you again.
Okay. Okay. Uh, me from my side, I have my
Yes.
homework, which one is the buffer lane from for the hologics, and I sent it to you, and the technical file to explain how the MPA works, and
Yes.
also I will share the procedures how to connect the swab samples in China, and just for your interest.
Yes. Yes.
That's the three things we yeah, I'm going to do, and I'll send you the document file. And for the file you sent to me, that's questions I will ask my colleagues and to give you written answers for the questions, because sometimes the language barrier, I may express myself very good. So that's why we use written answers, maybe easier for you understand what I say. Yeah.
Okay. Yeah. And just to give you an idea on the timeline, so we are trying. Most likely, we will meet the people with the university hospital probably within 2 or 3 weeks, if everything goes right. And then we might have like a presentation session and discussion with them, and then after that, I will inform you whether when they can proceed with the trials and what kind of instrument and software version they're using.
Okay. Okay.
Yes.
No problem. Okay. That's cool.
Yes, I will inform you before
Okay.
the presentation also. So just in case there's.
All right.
Yes.
Okay. Thank you.